Hey guys, it's Oppo. Welcome back to another video. In this episode, we're going to make our camera follow our player. So, let's go. In our last video, we kinda did this. We made our camera a child of our player so that it can follow. For some games, it's fine, but in my case, I want my player to be able to move freely without any restriction. So what do I mean by that? Actually, if my player rotates, since the camera is a child of the player, the camera is also going to rotate. So that's why what I'm going to do is make our camera follow our player through a script. Let's first create a script and call it camera follow. I know it's a weird name, but that's what we're going to call it, or at least I'm going to call it. And then let me just first unparent the camera. So I'm going to unparent the camera, then I'm going to drag and drop the script on the camera, and I'm going to open the script in Visual Studio. So how are we going to follow our player? So in order to follow our player, we need a reference to our player's position. So what keeps the player position? If we go back to Unity and take a look at the transform component, you can see the first option is position. So the transform component keeps the object's position, rotation and scale. So we're going to type public transform and I'm going to call it player. And I'm also going to remove the start function since we are not going to use it anyway. And in the update function, I'm going to check if the transform is actually working. So this is a good way to test your code, see if it's working or not. So I'm going to type debug.log and open and close parentheses, and in parentheses I'm going to type player.position and end that line with a semicolon. So what debug.log does, it's basically what it says, it debugs the code in the console. So if I now save the script and go back to Unity and make sure that I reference the player in the player section by dragging and dropping the player and hit play and bump up the speed, you will see nothing happens in the game view. But if we take a look at the console, you will see that it's updating its position and it matches with the position of the player transform. So following the debugging the player's transform is okay, but we need to follow it. So I'm going to exit out of play mode and go back to Unity, go back to Visual Studio and clear out this line and type transform with a smaller t dot position. This actually refers to the transform of the object that the script is sitting on, meaning the camera's transform. So transform dot position means the camera's position in this case is equal to player dot position and end the line with a semicolon. And now if we save and go back to Unity and press play, what happened? Where is the player and the platform? We cannot see anything in the game view, but if we go to the scene view, you can see that everything is there, but we cannot see anything through the camera. And if I just bump up the speed of the player, you can also see that the gizmos is following the player. That means the camera is actually following the player, but it's inside the player. If I just exit out of play mode and go to the camera's transform, you will see that X and Y value doesn't matter here, but the value that matters is the Z value. So if we take a look at the Z value, you can see that it's -10. But you can ask here that it's a 2D game. What does the third axis has to do with anything? In a way you are right, but in games how 3D works or how 3D camera works is it renders the object that is in front of the camera and renders the object that is far from the camera later. So right now what happens when I play, the camera goes inside the player actually, and inside the player I mean the Z value gets 0. So the player and the camera is sitting on the same layer, you can say. That's why the camera cannot render anything. So the easiest solution to this is offset the camera value by -10. So how are we going to do that? Let's go to Visual Studio, and in the up here type public, and right now what I'm going to do is type vector3. Vector3 is basically X, Y and Z, and I'm going to name it offset. Now if I just go here and type plus offset, it's fine. It might be a bit confusing for you at first, because generally we see adding two numbers or subtracting two numbers, but in this case we are adding two vectors. So how do we add two vectors? If I go back to Unity and here, so the whatever the X value here, the offset is going to add whatever I put here. Same goes for the Y and same goes for the Z. So when I play the game, the value of the XYZ becomes 0. But if I put -10 in the Z value, so everything is 0 and it's adding to that value, making the value of Z -10. So if I right now just play, you will see that everything works fine. And if I just bump up the speed again, voila, the camera follows the player. That's it. This is a fairly short tutorial or episode, you can say. And yeah, if you enjoyed the video, make sure you like and subscribe, and I will see you in the next video.